Hello, friends. I welcome you to this session of process design for operations in manufacturing. Here you can find a table matrix which shows some of the salient features of alternative choices which is available with respect to the flow characteristics. Here, three types of flow characteristics are given. The first one is continuous flow, then intermittent, and the jumble flow. Let's see some of the salient features in continuous flow characteristics. We can use continuous flow in operations in a manufacturing setup. Continuous flow is usually used for products with high volume and with very low variety. High volume products are usually manufactured in process industry like your sugar industry, paper manufacturing industry, and oil refinery industry. Since the flow has to be continuous and there is more maintenance work required as compared to other two flows, which is intermittent and jumble. Capacity utilization is the main aspect of continuous flow. As continuous flow has to be maintained, so high level of maintenance of the equipments and machines and the resources are must. And many times it sounds more advantageous to vertically integrate the supply chain in the flow of material in case of continuous operations in the process industry. So some of the management tools and techniques which are used in continuous flow are line balancing and maintenance management, process optimization, scheduling of the flow shop, and the scheduling usually is full type of scheduling. The second type of flow is the intermittent flow. The intermittent flow is usually used in case of mid-volume and mid-variety kind of products. Some example of the use of intermittent flow in production systems is the batch production, especially in case of discrete manufacturing, but it is also used in process industry wherever possible. Why batch production is because of the mid-range of varieties of products manufactured in this flow. So multiple varieties of products are produced and manufactured at a time. So therefore, batch production is appropriate in this case. Different product varieties are manufactured in different batches of mid volumes or small volumes. The main challenges and issues that comes in this intermittent in managing the intermittent flow is the manufacturing system itself and the layout design. It becomes far more complicated than the continuous flow. Changeover management is a very big issue in this intermittent flow operation system as multiple varieties of products are involved. Each and every times the machines have to be stopped after every batch production, and then machine setup has to be done again for the next batch. So changeover management is very crucial and very time consuming, and its cost to the company is too, and cost to the manufacturing too. Capacity planning becomes very difficult and challenging, and the kind of management tools and techniques, operation management tools and techniques used in intermittent flow is a very accurate forecasting of the demand is required in order to calculate uh, as accurately as possible the capacity to be manufactured. So capacity planning estimation is very crucial. That's why it depends on the demand forecasting, how accurate demand forecasting is. Again, scheduling and product sequencing is a challenge in this intermittent flow. Usually, group technology layout design is used in this kind of flow. The last one, jumbled operations flow. It is usually used for very high variety of products, but it will come with low volume. As every time a single variety of products is manufactured, that's why it will give a very low value. This jumbled operations flow system allows you to manufacture a different, entirely a different variety of product every time when it manufactures. And so it does make sense in manufacturing a single unit, but which is very huge in size in terms of volume and scale. For example, a project of IT companies, a single project used to be of huge size, but only one variety of project is undertaken at a time. Manufacturing of ship, ships, aircrafts, dams, hydro electricity dams, etc., will fall under this jumble flow. Here again, some of the issues and challenges lies with capacity estimation, scheduling, production control, cost estimation is very challenging, and some of the operations management tools and technique used here is basically dependent upon scheduling, project management, capacity planning and optimization, job shop scheduling, functional layout design, etc. We can further understand this flow and volume relationship along with some product examples in this product process matrix. On the top left corner, we can see the product satellite launching vehicle. This is a unique product which is manufactured as per the requirement of a satellite to be launched. So every satellite is different from another. So we can say that there are huge varieties from which we can manufacture a satellite, but then the volume is very low. Volume is only one satellite at a time. So in this case, we use jumble flow or job shop is the name of the production process. Second kind of products are products like machine tools, which are used in industrial maintenance and home maintenance, like those machines and equipments used by electricians, plumbers, etc. So we usually find huge variety and huge range of machine tools which are required for maintenance in a company because each of the machine tool will have different dimensions, shapes and size, and ability to handle different kind of equipments of again different shapes, sizes, and volumes. Therefore, these equipments are manufactured in multiple varieties but in the low volume. So the most appropriate kind of operation process will be batch production, and it is also known as disconnected line flow, which means not continuous line flow. The third type of products we can discuss, the third type of products can be taken as an example of few major products with high volume of production can be auto electric parts, like for example the headlamps of automobile companies, like for example the headlamp of the vehicles manufacturer like Mindas in India. They used to manufacture headlamps for all types of vehicles, or the automobile industry itself. They manufacture in very high volume but a few major products. So here the most appropriate production line or production flow will be connected line flow or the assembly line. And the fourth product example given here is polyethylene. Polyethylene is a byproduct of oil refinery from crude oil, is the end product, also one of the byproducts apart from petrol, diesel, kerosene, LPG, etc. So these products is manufactured in huge volume, but only one variety or a few varieties. So for this kind of product, the continuous flow is the most appropriate operation process in terms of the flow. Now, after understanding the product process matrix, the next thing we do in manufacturing operations is to design the layout, or layout planning is the next activity. Layout planning is nothing but is the physical arrangement of various resources, uh, whether it is in manufacturing as well as in service organizations. Basically, layout planning is deciding on the best physical arrangement of all the resources that consume space within a facility. These resources might be like any kind of resources. It can be machine, the man working on the machine, the positioning of the people, the machines, a cabinet, or a work center, or an entire office, or even a department. The main motive behind a layout planning is to carry out the operations process as efficiently as possible with maximizing the resources utilization by positioning the resources nearby close together and by removing the time and space among the resources so that the operations happen smoothly in less time with higher productivity and lesser cost. The final outcome of a good layout design is improved quality. We discuss a few types of layout here. There are four types of layouts discussed here. The first one is process layout. Process layout involves the arrangement of the resources required for production on the basis of the requirement of the process or the functions carried out during production. In a process layout, the floor plan is arranged with similar processes or machines located together. For example, a machine shop with mills are located together, lathes are again located together, painting shops together, and so on and so forth. In production layout design, the layout of equipment and processes in the workstations are distributed around the needs of the end product. Product layout is also known as assembly line layout. The third type of layout is group technology layout, GT layout, and it is also known as hybrid layout. It is kind of combination of both the product layout to a process layout. Basic concept of group technology is to identify and bring together related or similar parts and processes together into a group or a cell. So that's why sometimes it is also called as cell layout. The purpose is to take the advantage of the similarities which exist during all stages of design and manufacture. In a fixed position layout, the project remains in one place and workers and equipment come to that one work area. Examples of this type of projects are a ship, a highway, a bridge, a house, and an operating table in a hospital operating room. Here in this slide, we can see the process layout for product A, B, and C, where resources and machines having similar functions are put together in one place or department. See, all L are put together, and all D resources or functions are put together. Likewise, M are put together and G are put together. And the product A, B, and C are made to flow passing through these functions as per the requirement of the production sequence. This slide shows us an example of a product layout. In this layout, each of the product A, B, and C has got their own separate production assembly line, unlike process layout, where the different products passes through the common production function or department. The main idea behind group technology layout is to group similar processes and products together in order to increase efficiency, reduce production time, and lower costs. So in this diagram, we can see that the manufacturing area is divided into cells or groups of machines that are dedicated to producing a particular family of products. Cell 1, Cell 2, Cell 3, and Cell 4. This slide shows us the diagram of a product which is an industrial boiler of a huge size manufactured by a company called Thermax. Not only this product, but other products like airplanes, ships, buildings, or even heavy machineries follows this kind of layout, which we call a fixed position layout. Here, the product remains stationary. Equipment and materials are moved into and fro. This helps us in maintaining high degree of customization and efficient utilization of space, and the difficulty of moving such huge product dimension from one place to another place. With these, I would like to summarize the four types of layouts that we just had discussed: the process layout, product layout, group technology layout, and the fixed position layout. Thank you for listening.